What we're supposed to do in number 15 is evaluate this expression both when x is 2 and when it's negative 3. Now notice, this is an expression. There's no equation here. So these are just computing instructions. And what's coming in the first time is a 2. So let's separate these. Let's say, first of all, when x equals 2, here's what we're going to get. Replace all the x's with a 2. So we'll get 11 times 2 plus 6 divided by 2 times 2 squared plus 29 times 2 minus 66. So in the numerator, we'll get a 22 plus 6 over, in the denominator, now 2 squared is 4, 4 times 2 is 8, plus 29 times 2, that's 58, minus 66. In the top now, 22 plus 6 is a 28, and in the denominator, we've got this 8 plus 58, which is 66, minus 66. Well, this is going to give us 28 over 0, which is undefined. So 2 is not in the domain here. We cannot use a 2, because when we substitute it in, we do not get a number back out. We get something undefined. So let's try this then. When x is equal to negative 3, let's substitute that into the numerator. We'll get 11 times negative 3 plus 6 over, now in the denominator, we'll get 2 times negative 3 squared plus 29 times negative 3 minus 66. In the numerator, we'll get negative 33 plus 6 over, now, negative 3 squared is 9. 9 times 2 is 18. In the denominator, we've got this negative 3 times 29. Now, if that was a 30, 3 times 30 is 90, but we're 1 less 3 times. So that's going to be 90 minus 3, 87, but it's going to be negative. So we'll get minus 87 and then minus 66. So in the numerator, negative 33 and 6 is negative 27. And in the denominator, we're going to get a negative 135. And then it just turns out that these are reducible. Negative divided by negative is positive. And, you know, we've done this before, I think. These digits, if you add them together, 9 divisible by 3. These digits, when you add them together, you get 9, that's divisible by 3. So both these numbers are divisible by 3. So if we divide these by 3, we're going to get, let's see if we can do this, we're going to get 9 over 45. Now both of these are divisible by 9, so we're going to get 1/5. So when we substitute in 2, we get undefined. When we substitute in negative 3, we get 1/5. Now in 19, this is going to work pretty much like number 15. This is an expression, not an equation, so we're just evaluating. First at 2, then at negative 5. So first of all, if we say when x is equal to 2, substitute this 2 into here for x and into here for x. And when we do that, we're going to get 2 squared minus 4 over 2 squared minus 25. Well, this is going to give us 0 over 4 minus 25, negative 21. That's 0. So at 2, we get 0. But now, when x is equal to negative 5, we're going to get negative 5 squared minus 4 over negative 5 squared minus 25. In the numerator, we've got 25 minus 4, which is a 21. And in the denominator, though, we've got 25 minus 25, which is 0, which is undefined. So when we put in the 2, we get 0. But when we put in the negative 5, this is undefined. So 2 is in the domain, negative 5 is not. In this problem, number 21, we're supposed to identify all numbers that w cannot be. What's going to make this thing undefined? Well, we don't divide by 0, but we do not divide by 0, so we don't want this denominator to be 0. So 7 times what is going to be 0? Well, 7 times 0 is 0, so we are going to say w cannot equal 0, but it actually, to answer the question says find all numbers for which the rational expression is undefined. This expression is undefined when w is equal to 0. So we found the numbers that make it undefined. And in number 25, again, we're supposed to find all the numbers that make this expression undefined. So expressions are undefined when the denominator is 0. So what we're asking essentially is this. So you can probably see this. If you put in a 5, you get 5 minus 5 is 0. But what we're really doing here, and maybe we do it mentally, we say this. When x minus 5 is 0, this expression is undefined. And if we solve this little linear equation, we get x equals 5. So our answer to this problem is 5. We're asked to find all the values that make this expression undefined, and that number is 5. Same idea in number 27. Find all values that make this expression undefined, and expressions are undefined, remember, only when the denominator is 0. No problem with the numerator. That can be 0. The denominators can't. So what we're looking for is what numbers will make this thing equal to 0. So you might be able to see it with the work we've done before, right? You change the sign of the constant, -1 divide by 7. So I think what we're going to have here is -1 over 7. But here's how we would actually get it. We're doing this in our head. 7z plus 1, what's going to make that 0? So solve the equation. 7z is -1, divide by 7. There it is.